Hello, welcome to the first recording for Algebra 2 Honors. Right now, I'm going to discuss three sections with you. Sections 1.1, which is about applying properties of real numbers. After that, we'll talk about sections 1.2 and 1.3. First thing I want to talk about with 1.1 is a hierarchy of numbers. We'll start with real numbers. Real numbers are everything you can think of. If we branch down, we will get rational numbers, and irrational numbers. Rational numbers are numbers that can be expressed as a ratio of two integers. Irrational numbers cannot be expressed. I emphasize cannot as a ratio of two integers. Let me give you some examples. So, for example, 2, 0.5, 0.3 with the bar, those are all rational numbers. Because 2 can be written as 2 over 1. 2 and 1 are integers. 0.5 can be expressed as a rational number because we can write as 1/2. 1 and 2 are rational numbers. 0.3 actually I meant to say 1/2, 1 and 2 are integers. And then 0.3333 and so forth can be written as 1/3. 1 and 3 are integers. Irrational numbers would be numbers like this. Pi root 2. Because it's not possible to write pi as a ratio of two integers, nor can we do the same for root 2, because 2 is not a perfect square. So we start with real numbers, which is any number you can think of, and we branch down to two subgroups, rational numbers and irrational numbers. From the rational numbers, we could break down even further. So right below it on the pyramid or food chain of numbers, if you want to think of it that way, are integers. Integers are numbers without decimals. So examples would be the following. -2, -1, 0, 1, 2, dot, dot, dot. So we could have -50, -1,000,000. We have 50, we have 1,000,000. And of course, a bunch of numbers in between. Numbers larger than 1,000,000, larger is less than -1,000,000. So those are what integers are. Kind of like whole numbers, but you could have negative numbers as well. Below the integers will be the whole numbers. And we'll kind of stop after the whole numbers. Whole numbers, like integers, but no negative numbers. So we start 0, 1, 2, 3, 4, dot, dot, dot. They go on forever after that. So that's basically what we expect from all the properties of numbers. Next, I'd like to talk about graphing numbers on a number line. So let's look at that. Now remember, a number line could look like this. And let's say we wanted to plot the following numbers. Give me one sec here. See if I can make this a little thicker. Here we go. Let's plot the following. Negative 0.2, 7/10, negative 1, root 2, and negative 4. Now negative 1, we'll do that one first because that's kind of easy. That's right here. 7/10 will be between 0 and 1 because the numerator is less than the denominator, but it's positive, so it's got to be between 0 and 1. Negative 0.2, it's got to be to the left of 0 because it's negative, but can't be to the left of negative 1 because negative 0.2 is greater than negative 1. Root 2 has to be right between 1 and 2. The reason why is because, if you think about it, root 2 has to be between root 1 and root 4. Root 1 is 1, root 4 is 2, so we expect root 2 to be 1 point something. What it is exactly, you don't have to worry about so much. Just know it's between 1 and 2. And then negative 4 is right here. So if we were to rank these, you go negative 4, negative 1, negative 0.2, 7/10, and then root 2. So you'll have an opportunity to try problems like that on your packet later this week. Another thing I want to talk about regarding real numbers will be the order of operations, but that's not until we get to section 1.2. Before we do that, let's talk about conversion, converting units to other kinds of units. And then we'll end 1.1. So there's something that's called unit analysis. And here's how it works. Say, for example, you drive 45 miles per hour, want to convert to feet per second. So let's use a new color here. We'll try green. So 45 miles over 1 hour. That's what we originally have. Unit analysis is basically when you want units to cancel and of course get to units that you want. So start at time. We don't want hours anymore. So I'm going to put hours up top so you see how these just cancel. But of course, what's equivalent to 1 hour? 60 minutes. But we don't want minutes, we want seconds. So now I'm going to put minutes in the numerator of the next fraction, so these will cancel. I'll put 60 seconds below because 1 minute and 60 seconds are equivalent. Notice how this right here and this fraction right here each hold a value of 1. Because 1 hour equals 60 minutes. And of course when the numerator and denominator equal each other, the value is 1. So we're not changing the value of this right here. We're simply just converting it. And then finally, we want to convert the miles to feet. I never expect you to memorize how many feet there are in a mile, but just so you know, there's 5,280 feet in a mile. I'd give you stuff like that. I wouldn't expect you to know that. But do know how to make the conversion. So these go away. And so now we're stuck with miles. And I think I have a highlighter. Yes, awesome. Here we go. So we got feet and seconds, which is what we want. So of course you have to use a calculator to work this out. And if we do the conversion, or do the calculation, you should get 66 feet per second. Of course, using a calculator would be a wise idea here. So if you think about, like, let's say, I don't know, it's kind of a corny analogy, but if you're one particular religion and you convert to another religion, you're still the same person, right? But you just now follow something else. Or if you used to be a meat eater, but now you're a vegetarian, so you converted your eating habits, but you're still who you say you are. You're still, you know, Steve or Jim or whatever. So your identity doesn't necessarily change, but you just do something else. So I'm not sure if that really made any sense. It's early in the morning, but conversion really doesn't change the value, but it just changes the units. That's it. So now we officially conclude section 1.1.